Episode 1. What is electrical and electronics engineering? Have you ever wondered how your phone knows when you touch the screen? How electricity travels hundreds of kilometers to your home? Or how a tiny chip can control an entire satellite? Behind all of these technologies, there is one major field: electrical and electronics engineering. Welcome to the first episode of our podcast series, where we explore the fundamentals of electrical and electronics engineering, what it really is, and why it matters so much in today's world. Main explanation: what is electrical and electronics engineering? Electrical and electronics engineering, often called EEE, is the branch of engineering that deals with electricity, electronics, and electromagnetism. At its core, this field is about controlling energy and information. Electrical engineers focus mainly on power generation, transmission and distribution of electricity, large-scale electrical systems like power grids, motors, and generators. Electronics engineers, on the other hand, work with small-scale electronic components, circuits, chips, and devices, signal processing, communication systems, and embedded systems. Today, these two areas are deeply connected, which is why they are often taught and practiced together. A simple way to think about it. Here is a simple way to understand the difference. Electrical engineering is about power. Electronics engineering is about control and information. For example, electricity brings energy to your house, but electronics decide how that energy is used. When the lights turn on, how your laptop changes, and how your phone communicates with the internet. Real-life examples. Electrical and electronics engineering is everywhere around you. Your smartphone contains transistors measured in nanometers, complex digital and analog circuits, communication systems using electromagnetic waves. Electric cars rely on power electronics, electric motors, battery management systems, hospital use, medical imaging systems, monitoring devices, precision electronic sensors. Even the internet itself depends on signal transmission, fiber optics, communication electronics. Without electrical and electronics engineering, modern life as we know it would simply not exist. What do electrical and electronics engineers actually do? Engineers in this field design circuits and systems, analyze and solve real-world problems, simulate systems before building them, optimize efficiency, safety, and performance. They work in areas such as energy systems, telecommunications, robotics and automation, aerospace and defense, artificial intelligence, hardware, renewable energy technologies. This makes EEE one of the most versatile engineering disciplines. Why this field is so important? We live in an age of renewable energy, smart devices, electric vehicles, artificial intelligence, space technology. All of these rely heavily on electrical and electronics engineering. As the world moves towards sustainability and automation, the demand for skilled electrical and electronics engineering continues to grow. In short, if it uses electricity, signal, or data, an EEE engineer was involved. Closing. Electrical and electronics engineering is not just about formulas and circuits. It's about building invisible systems that power our world. In the next episode, we will explore an important question that many beginners ask. What is the difference between electricity and electronics, and why does it matter? Thanks for listening, and welcome to the world of electrical electronics engineering.